Now we are getting to the calibration. And this on the robot tab, it's a basic thing. To be able to show the distance that we have moved and how much we are turning, these figures need to be right. So one of them is the base, and it's also called wheelbase, WEB, and that's the distance between the rear wheels. And if the rear wheels, just like on this robot, is fairly wide, and the tires are fairly broad, it can be difficult to see which one is touching the ground, because that's actually what it is. It's the distance between the points on the wheels that are touching the ground. But I measured it something like 26.5 centimeters. I mean, it's 0.265 meters for this robot, but that'll be different for different robots. Then there's a gear, and this is definitely wrong. The gear in most robots is 10. That means the motor rotates 10 times every time the wheel rotates 1 time. So I'll change that, and I pressed edit before I could do that, otherwise it will override with what comes from the robot. And then on the motor there's an encoder, and it gives a number of pulses for each motor rotation. And it's not 48, it's 64. So I'll change that to 64. The gear is 10 on most motors. We have some motors with a gearing of 18, I think it is. You will find out if it's totally out in the forest, then the gearing is probably different. It also says at least on some of the motors, how far it is. But what we don't really know with any precision is the wheel diameter. And here we have the left wheel and the right wheel, and they are set slightly different. We'll leave them as they are and see how does the calibration work. And after that, we will, once we can control that, we will go back to turning. And the turning, it depends on the distance between the wheels. How much further should one wheel turn to turn 90 degrees? And if they are pretty close, then they should not drive as long. If it's further away, the wheels are further from each other, it should the one wheel turning or driving when the other one is still is much further. So the calibration of the turning, we can do that with the wheelbase, and the distance driven, we do that with the wheel radius. So that's what we do, and I have Melina set up. If I move this one, you can see she is set up here on the floor, and we have a ruler here, and 1 meter is over there somewhere below the other camera, and I have the other camera here, and we have got one wheel just in the center. I'll move that a little while because we need to set up a mission to drive a meter. So we'll go to the mission pane here, and I've made a short mission. I've started logging, and that's not really important, but we'll do that anyhow. Yeah, it doesn't matter too much. So we are standing still in the beginning. I could say velocity is equal to 0, but it will do that at the start of a mission anyhow. And then I have a command saying velocity equals 0.3. It should not be too fast because then it takes some distance to brake. I think 0.3 is good, that it will stop when you ask it to stop. And at distance equals 1 meter, and then velocity is 0. And I put in a time because once it finishes with the last line, it will release the motors, and that means their braking effect will also stop at that point in time. So it's good to force it to have velocity 0 for a little while, so that it will force the wheels to stop. Now we've got that, I will save it to the robot, and no errors, so it's on the robot. I don't need to save it to Flash because this is not essential. We should only use it once or until we have calibrated sufficiently. So that's it, and we will then, I'll remove this, and we'll have the other camera in to see when it reaches the end. And then I will press the start button, and I can use this one to do that. I will take control and then press the green button. That will start the mission. That's the same as I could also press the start button, but then we can't see what's happening. So I move this away and press the green button, and hopefully it will start. It does. And I ask it to run a meter, and we'll see. No, it didn't quite make it. It made it just from the wheel 97 centimeters. So it has rotated the wheels sufficiently so it thinks it's 1 meter. And if we look at this robot pane here, it says down here 1 meter and 1 millimeter. It thinks it has moved, but it only moved 97. And that means the wheels, it thinks the wheels are too big. If we tell it that the wheels are smaller, then it has to rotate them more to reach 1 meter. So that's what we'll do. So I'll move this out of the way. And here we got the wheel radius. And we're missing 3 centimeters out of a meter. That's about 3% that we are missing. And if we increase or decrease the wheel radius with about 3%, that means about 1 millimeter, 3 centimeters, 1% or 3% of that, that's approximately 1 millimeter. So we'll try with that. I'll say edit and reduce this to a 2 and reduce this one to 3. That was a little bit bigger. There's a slight difference, and that's something the wheels are not manufactured that equally, and that's what I've done to change to make it move straight forward when it should move straight forward. So that's another calibration you can do, and I've made it accurately a while ago. So we'll try with this. Try to say that 3% smaller wheels should give 3% longer distance. We'll try that. So I will save it. And now I save it to Flash because I would like to keep these values. So saying save to Flash also save the mission. No, but we don't care this time. We'll move it back. Try to make it straight. It should be okay. Maybe like this. Trying to be a bit accurate, and we'll do it again. And where did I do of this one? I will press the button and press the green button, and then it starts, and we will have a look, see how far it gets. And this was bang on. There will be a little bit of variation, but you can see it's not much. So now we have calibrated the wheel diameter, and if we think it's going straight when we ask it to go straight, then we shouldn't touch that again. And then we need to do some turning and see if the turning is okay too. So we'll do that. Yeah, now we have to do some turning, or get the turning to be right or as good as it can be. And you can see here that I have been some testing, but I will show you from the beginning how it's done. So I will reset all these circles. And what we need to change now is the wheelbase. And the wheelbase, that's the distance between the driving wheels. So we start by a ruler. So I have the little camera on the side here and a ruler layout along the wheels. And it's more or less aligned a little bit into the tire, fairly close to the motor. And when we read where the other wheel is, it could look like something like 24 centimeters. So that's what we will try. So I've set in 24 centimeters, and then we will see how it goes. And to do that, we need a mission. So again, we'll go to the mission pane here, and I've made a new mission. Just like before, I'll start with velocity 0, and I'll do some logging. It could be interesting to see a curve for that, and set that it'll start after, it'll stay on 0 velocity and logging for 20 milliseconds. And then we'll do some turning. I'll set the velocity 0.3 meters per second, and then a TR. That means turn radius 0.2. That means 20 centimeters. It doesn't matter too much if it's close to the distance between the wheels. That means that the one wheel will not go backwards, but it will more or less stop, and the other wheel will do all the turning. And otherwise, changing from full forward to full reverse for one of the wheels could give a little bit slip, that the wheel lose a grip on the floor. So we try to keep this turn radius a little bit bigger. Then I made a label. I'll come back to that. But after a colon, I say I want to turn 90 degrees. And then I go a little bit forward just to see what it's doing. Well, that's another reason. I'll come back to that. So we'll go forward 0.2 centimeters, 0.2 meters, 20 centimeters. And then the next line says go to 1. And go to 1, that means this label number 1. So the program will loop back to this line and repeat that. And there's a condition. How long should it use this go to? It should count to 3. So it should go back 3 times. And the last time it will then don't go to 1 anymore, but it will continue to this velocity 0 for a little while to break the wheels when we are finished. So this should make it turn, make 4 turns, so we should almost get back to where we started if everything is right. So I will save it to the robot. I can load it from the robot to see if it has understood it, and it looks exactly like what we wanted it to do. So if we are really in doubt, you can ask the robot, what are you doing in this way? Okay, so that's what we'll do. And we will try that mission. I will move the robot to somewhere where we can check it. So now it's more or less aligned with the camera. So we'll see how it goes. And I'll, just like before, press the green button to run the mission. And it starts by turning, and then goes a bit forward and turning, goes a bit forward, turning, a bit forward and turning, and now it should be back to where we started. Well, that didn't quite happen. So that means that our wheel distance is not as good as it could be. It could be much worse, but 24 centimeters was not the right way to do it. If we say that the distance is bigger, then it should turn a little bit more. You can see I've got it here. I say edit 24 centimeters. If we tell it the wheel distance is bigger, then the outer wheel should run longer, and we can see that's the problem, that this wheel haven't run far enough. So we will increase this to, let's try with 25 centimeters. And say save, and then we will try again. I'll just move it to the starting point, or close to a starting point, and align it a little bit. Yeah, so this is not too bad. Like that, and we will run the mission again. Turning straight. And if you could see that once it goes straight, it corrects it makes a little turn. yeah, this was quite good. That's the reason why, if you noticed, let's try it again. Then try and notice when it goes straight. I need to take control and then press the green. It turns a little bit, and that's because there's a heading control, and that knows what the angle should be. And if the turning itself was not quite correct, then it would try and correct it. So we tried exactly the same setting again, and it didn't give quite the same result. But so it means that we will make another test and see what are the variation, and I will run the mission once again. It was doing a little bit less than I would expect it to do, and let's see if we can repeat that. Yeah, it looks like a tendency. Okay, we will give it a little bit more. Not as much more as before, so maybe 25.4. We could try and use that. And this time I'll save it to Flash, because we must be fairly close now, and I'm not sure I will do it again, or I will can probably not be much better. There is some, whether it's the wheels or because it loses the grip of the floor, I'm not quite sure, but we will try and see if this slight increase should, so that the variations we have in the turning is half of the time too much and half of the time too little. Well, this looks fantastic good. So I will just try it again from there and see what happens. It also hits the tape, so maybe the floor is not that even, but that was 2 times quite okay, so we will try a 3rd time. Yeah, this time it got a little bit further, but there's a little bit of variation. And if I look at the track that it made, we can see many of them. You can see it's here right now, and it thinks itself that it's got to the right place, and it will more or less do that every time. But there are some variations on the go, and that is partly caused by these fairly wide tires. Wide tires are good for many things, but the precision driving is not one of them. Yeah, so we'll not do anything more than that. We think this one is really good, and it means that this distance, which is how far did it get? It's 1.5 meters or something like that. That we can run that with a precision of maybe a couple of centimeters. So this is the accuracy we can expect from the robot. So if it runs 10 meters, then it's probably 10 or 20 meters away from where we believe that it should be. So we can drive some distances with some accuracy, and we also know that there's some limits to that accuracy. So that was it for the driving position.